Here we are going to do activity B for day 4, epsilon delta proofs for the limits of linear functions. Okay. So did you read through that? No, wait. You watched her video, right?
Yeah, I watched her video.
So in that video, it says something like, you have to write that long thing, like for every epsilon greater than 0, there exists a delta greater than 0, such that the distance between f of x and the limit is less than epsilon when the distance between x and a is less than delta. So I suppose like you kind of have to write that in the beginning of every one.
Yeah.
And then, so let's see. Then I just go on and start writing, like.
Yeah, basically you just prove that it works or that it doesn't work, I guess.
Yeah. So, do you know how to do it?
Well, I guess what really confuses me is the first part. I can understand the limits and if it does hit the limit or if it doesn't hit the limit, but I guess I don't really understand what the epsilon delta really does.
So, on the oh, that's you. Okay, so the epsilon is on the y-axis, and the delta is on the x-axis, right?
Yes.
So what it's essentially saying is that when an epsilon is greater than 0, it means that it's not on the limit, like it's away from the limit.
Yeah.
On the y-axis, and that will create, like, so if you have that, if you want to find that within a certain range, the delta is also greater than 0, and it will have to be within that range on the x-axis
as well. Okay.
Does that kind of make sense?
Yeah, it does. I guess the other thing is I don't really understand what we'd really use it for. I think it's my other question too.
Oh, let me look up. One second, my thing. Oh yeah, so Matt's out of town. His internet is down, so he can't.
Well, that stinks.
Yeah. All right. So what was I going to look at? Which chapter was it in the book?
It is number 32.
Precision definition limit?
Yeah.
Okay. So I don't really know exactly when you would use it.
Yeah.
Well, I mean, if you want to set up a range, like you want to get, like it shows here, like within 1/100th, like you want the error to be no more than 100th or 1,000th of the limit. So then you can find an interval where you can satisfy that.
Okay.
So essentially is that you want, like you have the limit at some point.
Yeah.
Often you can't really use the limit depending on, like, because that one doesn't exist or something like that. So
yeah,
depending on how close you want to get, to the limit, you can use it.
Okay.
Basically,
Basically, you just figure out how close like the equation is really to the limit. Okay.
Well, like how close do you want to get? So if you want to estimate an error, like you want it to be like within 1,000 close in between, so that you know how, like basically you can choose how accurately close you want to be to the limit.
Okay.
In a sense, I guess. From what I understand.
Yeah.
Does that make sense? Yeah, no?
Yeah, it does. I guess it's just now writing all the equation.
Right. So if we look at the first one,
go ahead.
So the limit of 3x plus 1 as x approaches 3 equals 10. So what I do first is set like an absolute value sign and have like 3x plus 1 minus 10 in there.
Okay.
Is less than epsilon.
Okay.
When the absolute value of x minus 3 is less than delta, and x is not equal to 3.
Okay.
So I guess what that is saying is that like 3x minus 1 absolute value is less than epsilon. Epsilon is less than, no, that's less than epsilon. When, yeah, so you're essentially just finding like what kind of ranges you have, like the functions. Yeah. And then you kind of factor absolute value of 3 out of the 3x minus 1. So you get like absolute value times absolute value of x minus 3 is less than epsilon, when absolute value of x minus 3 is, I wrote greater than, but I'm thinking it should be less than. Yeah, it's less than.
Okay.
And what you can do then after that is that, like in the beginning, you have like the 3 absolute value 3 times. Well, you have the absolute value of 3 times the absolute value of x minus 3 is less than epsilon. So if you take the divided by 3, you can take out that absolute value of 3. So you get absolute value of x minus 3 is less than epsilon divided by 3 when absolute value of x minus 3 is less than delta.
Okay. And I guess would that be the last part?
Yeah, but then you have to state it. So they wrote kind of like, even if you don't understand everything, just do it, and
just write it.
Right, pretty much. I mean, what I get from that is kind of that interval of, it's like either 3 times smaller or 3 times bigger on the y-axis or something like that.
Yeah, so I guess I understand it pretty good. It's just remembering everything that you have to write.
Yeah. And then I wrote like let delta be less than or equal to epsilon divided by 3. Then every x in the delta interval around 3 will produce a y in the epsilon interval around 10. Therefore, the limit of x 2x plus 1 equals 3x plus 1 equals 10 as x approaches 3.
Okay.
So then it's just like 3 more of those.
Yeah, they're all pretty much the same.
Yeah.
Yeah, I don't have any other questions. It's just kind of repeat. I guess will all of them work out perfectly, or is there some that don't
Well,
equal?
well, if you think of it, like you're proving something.
Yeah.
At them, like as x approaches 1. Like if you think of it graphically, you can look at them and say like, yeah, that's gonna be true.
Yeah.
And all of them is looking fine to me. Yeah. So then you essentially just prove that this is true.
Okay.
So that's pretty much
That's
what
not
you
too
do.
bad.
Yeah. I mean, I don't really think we need to do more. Like, just do that same thing. Like,
Just with all of them.
Huh?
Just with all of them.
Yeah.
Yeah.
I mean, we could like. If you have any other questions, or I have any other questions, we can talk about that. But,
I don't have any other questions right now. Do you?
yeah. Well, so what I found hard was on Monday's prep for Tuesday. Coming up next week. So like.
Oh, that the next week.
I was like, oh, this one would be good to do as a group. But, like I figured it out.
Yeah.
As I did today's day. But you have to like write things in a fraction, and that can be kind of tricky with some things.
Mm-hmm.
So just saying, but what I did, like I looked at the first activity for the next day, and tried those, and like the key helped me like figure out like the pattern on how to do it. So, and then I did the homework problem, so it worked fine. But yeah, I don't know. But do you want to do any more, or call it good there?
I think that's good. I guess I can't really help you a lot with Tuesday just because I haven't really got there yet. You know.
Yeah.
I wish I could. I wish I was smarter. I wish I knew it all. Don't we all? Don't we all though?
It was kind of tricky yesterday, but I did figure it out. But
yeah.
Cool. Well, so let's try it next week again, I guess.
Sounds good.
Cool.
Let me know if you need anything.
You too. I'll send the link.
Okay, sounds good. Thanks.
All right. Bye.
Hey, when are you taking the test?
Oh yeah, tomorrow.
Tomorrow? I'm going to tomorrow as well. So
Mhm.
we got a lot to study for.
Yeah.